Okay, continuity basically means everything connects. That's essentially what it is. So what's going to happen is the formal definition is the limit as x approaches a of f of x equals f of a. What that means is the point exists, the limit exists, and the limit and the point equal each other. That's the three criteria. Basically, if I had to write it very succinctly, you would say 1, the point exists, 2, the limit exists, and 3, they equal each other. And that's the definition of continuity overall, is they're going to go ahead and connect. So the issue then arises of when is it not continuous, okay? So that would be called, well, instead of continuity, we're going to now talk about discontinuity. So discontinuity is when they do not connect, essentially, and there's 3 different types. You're going to see vertical asymptotes is a point where you would not have a continuous function. So asymptotes, that looks right. Okay. This is also known as an infinite discontinuity because it's going to go up and down forever. So that's one different type. Another one's going to be a hole, okay? Holes are known as removable discontinuities. Removable. Let's see, removable. Okay, that's right. Okay, just making sure. Again, spelling. I'm math, not English. Okay, removable discontinuities. Let's see. And then the last type is going to be what's called a jump. And in general, it's just called a jump discontinuity. Discontinuity overall. Now, how do these occur? So vertical asymptotes, as you recall, is going to occur a lot of times relating to what's called a infinite limit. Okay, so if it's an infinite limit, where a lot of times you get some number over 0, that might occur. Removable discontinuities might occur when you have what's called an indeterminate form of 0 over 0 limit, or, of course, when you have a piecewise function, and let's say they both equal the same number, but it's not defined. And then a jump discontinuity will happen also with a piecewise function, where it literally jumps from one to the other. So there's a jump overall. This also occurs when you have what's called a 0 over 0 indeterminate form with an absolute value overall. So if I want to kind of like divide and conquer this, we've got this piece right here, and we've got this piece right here, and the piece on top. So if I want to basically summarize this real succinctly, I could basically go, okay, it's the difference between 1 over x, x over x, and that's a value of x over x. 1 over x, if you actually graph y equals 1 over x, you'll get a vertical asymptote at x equals 0, so that's going to be a vertical asymptote discontinuity. X over x reduces, leaving you with a hole. Absolute value of x over x, you'd have to approach the limit from each side. If you did that, you would actually go from -1 to +1, which would give you a jump discontinuity. And these all occur at x equals 0 in these 3 cases. So if you really wanted to summarize something real succinctly, this would work out really well, because if you encounter a question where they go, hey, let's go ahead and see if you can identify based on the function itself what kind of discontinuity we have, you might see something along the lines of let's do x times x plus 3 over absolute value of x, x plus 3, and x minus 2. And so in this case, I'm looking at discontinuities, numbers not in the domain. I'd say, well, I know at x equals 0, x equals -3, and x equals 2. That's from the bottom. I know that it's not in the domain. It's going to be a discontinuity. The x plus 3 is reduced and tell me I'm going to have a hole right there at x equals -3. These don't reduce. It's coupled with an absolute value, which tells me I'm going to have a jump at x equals 0 in this case. And then at x equals 2, well, it's on the bottom. Nothing cancels. There's no match on top. That's going to be a vertical asymptote or an infinite discontinuity. So that's dealing with the foundation for the difference between continuity and everything connects versus discontinuity. And to kind of wrap this all up, if I want to do one more here, let's do one more. Let's say I gave you g of x is a piecewise function. So I mentioned piecewise functions here. So let's say I did something like 2 minus x when x is less than 0. Okay, then we're going to go when x is between, let's say, 0 and 1 overall. And for this one, we're going to go ahead and have, let's do the square root of x plus 4. And then when x is greater than 1, we're going to have just a 3x here. And so what I can do is I can go ahead and evaluate the limits. So I can say the limit as x approaches 0 from the left, the limit as x approaches 0 from the right, and the limit as x approaches 0. I can also limit as x approaches 1 from the left, 1 from the right, and limit as x approaches 1 in general. This is all for g of x. G of x, g of x, g of x, g of x, g of x. Six different questions here. Okay, 0 from the left is less than, so that would be approaching this side. You plug in 2 minus 0 gives you 2. 0 from the positive end, approaching greater than 0. Plug in a 0, 0 plus 4, square root of 4 gives you 2. Oh, hey, what do you know? In this case, 2 and 2 it matches, giving you a 2. 1 from the left, that's less than, so it's approaching this side, this function. Plug in, you get just a square root of 5. And just leave it like that, square root of 5. 1 from the positive end would be greater than 1. Plug in a 1 here, and 3 times 1 will give you 3. So in this case, the limit as you approach 1 from 2 sides does not exist. Furthermore, it's a good, follow. Furthermore, what else can we talk about here? Well, let's talk about some discontinuities. At x equals 2, what happened? It's actually continuous. The reason why it's continuous is because the limit exists, the point existed, and they all equal each other. If this little underline, if that little thing right there, if it was not there, okay, just like that, then they would have met, but the point wouldn't exist, and it would have been a discontinuity. It would have been a hole then at x equals 2, but we've got that. So it is continuous. So do be very careful. Little details. At x equals 1, well, at x equals 1, you'll notice it jumped from the square root of 5 to 3. The limit did not exist. That is a jump discontinuity. So there you go with dealing with different types, whether it be the function itself or a piecewise function, making sure you can identify discontinuities and also know what is the definition of continuity.